Hello and welcome to another episode of Invalid Entry. My name is James Taylor and today we're going to be doing Koche Snowflakes using robots. I've got a little robot here which will go draw lines on the surface. Before we get started though, you obviously build your robot and you program it. I've got here a very simple program, and the first thing to do is calibrate, and I have a couple of little helpers with me here today who are going to help me with the robotics part. First thing you do though is you make a program like this, and the more important part is we're setting the degrees to 90 degrees. So that when I actually run this robot, you might be able to tell one of the motors, even though it's set to 90, get the camera in the right place, that camera, is actually turning around, the other one isn't. And that's to do with trimming. So what I need to do is take this apart, trim the servos slightly so that when it's set to 90, there's no movement whatsoever, and then we're good to go. If I don't do that, otherwise what will happen is instead of drawing a straight line, it'll always draw a curve and our pictures will be off. Okay, so in the previous episode when I showed you the snowflake, I basically said you start with two coordinates, you sort of imagine the line between them and you work out a third the way along, and then you work out a coordinate here, and that then gives you your snowflake by drawing those lines to those coordinates. If you're a robot, you don't necessarily need to work out these coordinates in advance. You can basically, I'm going to move a unit forwards, then I'm going to turn to the left or the right a certain distance, I think it's 30 degrees or whatever it is, go move 1 unit forwards, then turn back a fixed degree forwards, turn that way again to your left again, and go forwards. And then when you're drawing fractals, you can do one or two things. You could say, instead of going forwards an entire unit, I can go forward a third of a unit. Or you can say, no, actually when I got to the end here, I can just continue that. I can turn back, go forward a unit, and turn back again. So I go forward another unit. And basically what you find is that these two lines are obviously parallel, but this line and this line are parallel, and this line parallel, and you end up with these fractal shapes coming out just by going forwards, turning, going forwards, turning. And that's a lot easier to do than work out coordinates and moving to those coordinates if you're quite a primitive robot.
What type of icing that's used to decorate cakes generally?
Okay, so now that the servers are trimmed, we've got a new program here. This program basically is to allow us to work out how fast the motors go. So 0 to 90 is basically forward. So I'm going to go forward for a second at a moderate speed. We'll see how fast that is. And then what we're going to do is we're going to turn. I'm going to make the right hand wheel P1 go as fast as possible. P2 is going to go backwards. I'm going to turn for 100 milliseconds, and then we'll go forward again, both forward again for a second. I'm going to put in a second actually. Another pause, and what we're going to do, I'm going to record that, and then we're going to measure all the angles, and that will give us an idea of how much it turns so we can actually do it again. I've had to weight down the back of it a little bit, and I'll just see some batteries together. Let's just wait in the back, because when it tips forward it sort of drives itself into the floor. What I'm going to do here is just copy these two in here as well, so it actually freezes when it gets to the end of the run. So we'll give a quick whirl and we'll see how it looks. I always want P2 to be after P1, just for consistency. So let's give that recording a go. Okay, so I'm going to talk to the code as it is right now. Basically what I've done is I've made two sub-functions. One is a sleep function which just basically stops the motors for 200 milliseconds. I've got a function called go forth, which means to go forwards, and it sets the pins going forward and backwards. And then I've got this turn function which takes a flag and it decides whether or not it's going to turn to the left or the right. What's really weird is that I think here the motors aren't quite, I don't know, I'm putting in -10, so that has an impact. What we can then do is we can then basically say a star is basically by going forwards, making a turn, going forwards, turning much more to the left, then going forwards again, having a turn and go forwards. By the way, at the end of each of these functions I put a sleepy. I did have a sleep in between each one, so it just made the program very long. So this should just draw that very straight line. The reality is it doesn't, so I'm just going to play around these numbers. There's a bit of drift going on, but I think also that it struggles to turn to the left. It's much easier to turn to the right than turn to the left. So I will come back to you once I have that done. As you can see from the video there, it does draw roughly a straight line between 2 points, or there's a lot of drift. It does turn back, so that is basically the first order snowflake. What we're going to do now is basically take, I realize my mouse may have disappeared. We're going to make this into a function, so we're going to grab the make a function button, first order, we're going to call this, drop it in there, and then take the entire block and drop it in there. So what we now have is the ability to make first order Koche curves, and really it's just a matter of repeating this again, but this time calling the first order rather than the second order.
And I only like to look at pictures.
I think this may be a two-part episode, and the reason is I've just realised that I was trying to do this all in Scratch. This isn't Scratch, this is MakeCode, but it's basically Scratch. And the issue here is that depth here is going to be a var set in the total, so I've written this all in Scratch. But I actually need a local variable here, or I have to use num-1 in all these places, which I could do. I could say if num-1 equals 1 there, I guess I could do that. And then here, basically, what we're going to do is we're going to do these turn functions, but instead of go forth, we're going to have call curvy. So basically, call curvy. It's going to call curvy with num-1 as a block, because I don't have a local variable. So it's basically going to recalculate the number continuously. Then it's going to call turn. Then we're going to do call curvy again, and then we're going to call the next turn, which is the turn back, which is that one. Then we're going to do call curvy again. Then we're going to do our last turn before a final call curvy, and then what we're going to do is we're actually going to show a different icon at this point, because we're going to show the heart, I think, like that. There we go. So basically, if the number is greater than 1, it's going to go through this loop. All of that should be in this else, like that, and then that comes off the bottom. That. So basically, it's going to flip hearts at the end. And let's give that a go. I've got to plug everything in, and I've got to give it a quick run through. Okay, so we're going to call it there. This was the trace of the most recent plot. Basically, what we've got here, from here to here is a first order, and then similarly there's a second first order from here to here. It then tried to rotate around, because when you do your first order like that, you then have a second order like that, and then there's a large turn there, and that's what that is there. But I've only got a large book under here, so if it's going to get big, I'm going to have to take it into the kitchen. The other thing is I'm probably going to take it into the kitchen area, because I don't want it running off onto the carpet and drawing Sharpie all over the carpet. But this is basically drawing most of a Koche snowflake. This curve here is a bit not great, but weirdly this curve here, which is the same value, and this curve here are great. So we need to look into a bit why we're not quite getting consistency. But that's going to be it for today. So please see tomorrow to see if we have any more progress tomorrow.